Thank you for watching this video. This is part 2 of a 3-part series for Mobility Week, and today we are going to focus on new urban development and complete streets. Your presenter today is myself, Willem Bouwer. I'm the Business Development Manager, Civil and Transportation for Transoft Solutions, EMEA. The 3-part video series for Mobility Week started with safety concerns at intersections and roads where multiple modes of transport share the same space. And the one for today is about success stories, new urban development, and complete streets. And the last one will be future cities and how they could look like in future with less modal conflicts and a safer shared space for micromobility and walking. Topics covered today is complete streets principles, shared urban spaces, including the superblocks model, success stories, and then advanced straight path analysis of these improvements as analyzed in AutoTurn, and then a quick introduction to our next video. The complete streets concept takes what you see here and it changes the focus to pedestrians, cyclists, and transit riders, and less on cars. The street space is then totally transformed into dedicated cycle lanes, lanes for cars and lanes for transit, and safe walking areas. The next concept is shared urban spaces. And a shared urban space is an urban design approach, and that minimizes the segregation between modes and road user. So it's all more mixed. And this is done by removing or minimizing the features like curbs, road markings, traffic signs, and traffic lights. And shared spaces can take on many different forms, and there is no single way to design them. Some features of shared spaces can include the following. The center of the street is a shared area and is used by all types of users. There are no curbs, and it makes it for a seamless experience throughout the space. Limiting level separation between modes makes it easier for vulnerable users like people with limited mobility, wheelchairs, and strollers to move around in the space. There are pedestrian comfort zones, and they consist of obstacle-free pedestrian routes where pedestrians can move around more safely without the risk of conflict with other users. And where possible, these zones are aligned to the proximity of the building faces, and they are normally wider than standard walkways. There is soft lighting created, and it creates an atmosphere that makes all the users clearly visible. There are well-designed drainage that blends into the environment. There are furniture zones with shaded trees, seating, trash and recycling bins, bicycle parking, and other comfort items are aligned with light poles where possible. There are places for people to gather and rest and mix throughout the space. Raised pedestrian crossings and raised intersections reduce traffic speed. There are tactile warning strips, and they are used at entrances to the shared space and throughout intersections to indicate a change in the environment, which is necessary for people with limited vision. Then there are sound beacons and audio signals. These are used also to inform blind or visually impaired pedestrians that they are in a shared street, and these provide information on its operation and the presence of detectable surfaces, like the tactiles. In a similar way, at gateways, which are the entrance and the exit to this area, there must be information to notify the people that they are entering and leaving a shared space. And on-street parking can be accommodated if required, and information guidance is required to help people use the space. And this could include signs, kiosks, auditory cues, as well as information provided to apps that are on your cell phone. This is an example of a shared space It's Exhibition Road in London, UK. This is the aerial view just before it was completed. It's 800 meters long and in some places 25 meters wide. It was originally a two-lane car traffic type of road, and had narrow footpaths and 3 rows of parking, one on either side of the road and one in the middle. And it was remodeled and completed in 2012. The speed limit was reduced, and the calming effect is definitely seen when pedestrians and vehicles share the same space. This is the southern end of Exhibition Road. The night view shows street lights that are 20 spaced at 25-meter intervals. They are 20 meters high, and they create a very pleasing atmosphere during the night. This is Exhibition Road again outside Imperial College. This is the pedestrian comfort zone. And you can see that there are specifically designed tactiles to inform visually impaired pedestrians to safely navigate through this shared space. The superblocks model, I want to explain that, and that it is a model based on taking 9 blocks on a 3x3 grid, like you can see here. Then the principle is to close off the inner streets to cars. The traffic is diverted to the outer streets, and this is then the superblock. The next diagram shows that limited vehicle traffic is allowed inside the block. There will be streets that are earmarked for buses, last mile deliveries, and was shared with bicycles and pedestrians. And traffic inside the block is calmed, space is greened and remodeled, and there are more living activities happening inside these superblocks. In Barcelona, superblocks were implemented. Barcelona's got 60% of the public space is designed for cars, and only 20% of the movement in the city are actually by car. So there's a great opportunity for improvement, and this is why the Superblocks program aims to reduce the car traffic. It reclaims the public space for pedestrians, bicycles, and public transport. And in this example of Sant Antoni, you can see it's more playful environment. There were more elderly friendly spaces created, pedestrian flow increased, cars decreased, and pollution was reduced as well. This example shows a before picture of the street where each mode was clearly separated, and the change now is a more livable area for pedestrians and people. Again, here is a road that allows for more motorized traffic, which includes bikes, and it will include cars and delivery vans in this space. In this example, I'm going to show you vehicle sweep path analysis that was done in AutoTurn. And this specific area is the Sant Antoni area in Barcelona, Spain. And you can see that I've traced some of the space already in yellow. I'm just going to zoom in a little bit more. And you can see I've traced it in yellow. And then I've done a sweep path analysis already with a bus. And you can see at the entrance to the super block, the turns are 90 degrees to reduce the speed of vehicles entering the protected super block area. So this simulation was done in 2D. I just want to show you how to convert it to 3D if you had a 3D space. So there's no space selected, so I'm just going to use the XY plane in this case. But just to show you what a 3D simulation will look like. I'm not going to delete the 2D simulation, but I want to show you what this simulation could look like in 3D. And so in AutoTurn, you can place or remove vehicles. So there's 2 there. I'm going to remove 1. So this is what the simulation looks like in 3D. And when I animate it, just to show how this vehicle turns into the super block, I will click on the animate button, select the animation, and then I will change the speed to about 10, and I will click on animate, and you can see how the bus will move and turn into the superblock area. This is good for visual presentation. And you can see I've also added a delivery vehicle, because in this street entering the superblock, multiple modes will be allowed. There's a dedicated bus lane, a lane for cars and delivery vehicles, and then also for cycling. You can see on this road that this street is now really a urban space where you have dedicated areas here for people for gathering. You have walk spaces. You have an area for bicycles. And if the odd car does come in here, there are speed reducing measures in this area like speed humps. So I'm going to show you in auto turn a simulation of a bicycle entering. So in this case, I'm going to use a cargo bicycle. I'm going to start my simulation with a 2D arc path. I'm going to zoom in. I'm going to place my bicycle here. I'm going to start my simulation. Speed probably on this section will be 12 kilometers an hour. But as you approach this intersection and bicycle lane, you would want to reduce your speed. Otherwise, you will not make the turn. And so I'm going to use a function here called corner path that will just assist me to turn in here. And you can see when you do touch on the traced areas that are my boundaries, it'll show you if there are conflicts. So I've just created conflicts here, so my simulation will show conflicts. However, I'm going to place this neatly so that I can actually enter this area. I'm going to continue my simulation, and I'm going to stop it here. I'm also going to show in the next example, inspect simulation. And in inspect simulation, I'm going to evaluate speeds and just the maximum speed. And what you will see when I click it on this one, that the green is the acceptable speeds, 9 to 15 kilometers. Now for your specific design, you can change this so that it's perhaps 9 till 10 or 12. It depends on the specific design. And then you get a heat map like this. When you look at the heat map drawn by inspect simulation, you can clearly see in the tight turn that it's green, so it's within the acceptable limits. And once you go out of the turn in the straight sections, the bicycle is capable of higher speeds. And this is where calming measures are employed to still reduce speed. I want to show you also the bus simulation, also with the speed simulation. And I'm just going to delete the 3D so that we can clearly see it. I'm going to click on inspect simulation. And I'm also going to look at maximum speed. I'm going to click on inspect simulation. And again, what you can see is round the tight corner here, speeds are within the desired speed limit. And as the bus goes into this road, it is capable of driving faster. Speed calming measures are then employed to reduce speed within the superblock. Thank you very much. I'm going to go back to the final presentation. In our next video, we're going to show you what a future city could look like. There will be less modal conflicts and a safer shared space for micro-mobility and walking. Please contact us if you want to learn more about the topics discussed today. You can contact us and send us an email at info.eu@transofsolutions.com. Thank you very much for watching the video, and I hope to see you soon.